Hey everyone, welcome back to Cruise class. In today's lesson, we'll be looking at a very important topic, the coefficient of correlation. Now, the coefficient of correlation is a measurement that measures the strength of the relationship between two variables. Now, points to note, the correlation coefficient ranges from -1 to +1. The negative values indicate an inverse relationship, while the positive values indicate a direct relationship. Direct simply means that as one variable increases, the other variable increases in proportion as well. While inverse indicates that while one variable increases, the other variable decreases proportionally as well. So that is what the correlation coefficient is, and these are just a few characteristics. Now, one important thing that we need to understand is that it is represented by a common R. So when you see a common R in the statistics, it is usually representative of the correlation coefficient. Now, here's a little chart that I saw once, and it is fairly accurate, and we can use this chart to comment on or make any form of interpretation of our correlation coefficients. Now, as we can see here, values of -1 indicate perfect negative correlation. Values of +1 indicate perfect positive correlation, while value of 0 indicates no correlation at all, and values of -0.5 or +0.5 indicates moderate negative correlation or a moderate positive correlation. Now, if we have values, if we have values between 0 and -0.5, it will be considered a weak negative correlation, while if we have values between -0.5 and -1, it would be considered a strong negative correlation. The same thing applies for the positive side. If we have values from 0 to +0.5, any value within this range would be considered a weak positive correlation, while if we have values ranging from 0.5 positive to +1, it would be considered a strong positive correlation. So if we were to get a correlation of 0.83, for example, positive 0.83, that would fall between 0.5 and 1. So we could consider that as a strong positive correlation. Let's say we get a value of -0.31. -0.31 would range between 0 and -0.5, so that would be considered a weak negative correlation. So this chart can be very helpful in commenting on or interpreting our correlation coefficient. The next important thing we need to learn is the formula for calculating the coefficient of correlation. Now, let's go to our key. This means sum of x, sum of y, sum of x times y, sum of x squared, and sum of y squared. Now that we have that, we look back at the formula and we see the correlation coefficient R is equals to n, and n is just simply the number of data points. So it'll be n multiplied by the sum of x times y minus the sum of x multiplied by the sum of y, all divided by the square root of, open bracket, n multiplied by the sum of x squared minus the sum of x all squared, close bracket, multiplied by, open bracket, n multiplied by the sum of y squared minus the sum of y all squared, close bracket. Now it looks very intimidating, but I promise you it is simple, and we're going to look further into an example in our next video.